Let's have a quick look at this test. Test number 1, a dot will appear on the screen for 16 milliseconds. Don't blink your eyes and I want you to see and remember the color of that dot. Did you see it? Again, a dot with different color will appear for 16 milliseconds. Check what the color is. Did you see this one? If the colors you saw were red and green, you are right. But wait, let's have test number 2. Tell me what color you see now. 90% of the viewers saw yellow. If yes, then you are wrong. The colors shown on the screen were again red and green and shown for 16 milliseconds each. But instead of showing individually, they were shown back to back. If you saw red and green, then you are a really quick observer. But don't worry, if you saw yellow, it's normal. But what do these tests show? This test and many other examples in this video will help us understand today's topic. How many FPS are there in human eyes? And what's the resolution we see the world in? We don't see this world as we see videos. Video is a kind of slideshow where there are thousands of individual images rapidly changing every second. This gives us the illusion of motion inside a screen. Images that are rapidly appearing are called frames, and the rate at which the frames are appearing is called frame rate. 30 FPS means 30 frames per second, and 60 FPS means 60 frames are being shown in each second. The higher the frame rate is, the motion looks more and more smooth and clean. There are videos and games with frame rate as high as 120 FPS, 90 FPS, 240 FPS, and more. But can your eyes even see it? Now, let's bring the test we did at the beginning of this video. The first test had 2 videos of 1 second each. Both were 60 frames per second. The color was shown only for a single frame inside 60 frames of that second, which is 1/60th of a second equals 16.67 milliseconds, and you were able to notice it. But when those same colors were shown constantly for, again, the same interval of time, they somehow blend in and create yellow. Instead of 60 FPS, even if we use 220 FPS, like in an experiment done on pilots of Air Force, they were able to see and recognize the jet even when shown for 4 milliseconds. But again, showing them constantly made it unrecognizable. So to understand the FPS of our eyes, we need to find the lower and upper limitations of its ability to perceive rapid changes or motion. But our eyes don't record everything at same clarity. Instead, eyes track a single object that we want to see. Like when you try reading this, you will read each word individually. You cannot see all the words at the same time. Everything else is visible but not clear. Farther the other objects are from the focus, it becomes less and less visible. So while watching something in motion, the speed of that object decides the frame rate of our eyes. So in the test where the colors change back to back at an interval of 16 milliseconds, your eyes tried to track the first color, which changed almost instantly. That's why a lot of people failed to notice both colors individually, which turned into yellow by blending together. Many people did notice, but since we are finding the average range, 16 milliseconds, which is 60 FPS, is the upper limit after which average eyes cannot track single frame efficiently. But that doesn't mean you can't see higher frame rates. Higher the frame rate is, smoother the motion is. But it's just hard to tell the difference. Like, we are able to tell when comparing frame rates between 30 and 60 FPS. Also, the visual information sent by our eyes to the visual cortex of our brain is stored for 1/15th of a second. So that means if animation is moving at 15 frames per second or higher, it will look like it's in motion. Not butter smooth like in 60 FPS, but it will at least look like it's in motion. So the lower and upper range of frame rates up to which average eyes can see and tell difference is 15 to 60 frames per second. But technically, the range which matters to us when watching videos or playing games is 30 to 60 FPS. Having higher frame rates will look better and smooth, but this range is what your eyes most care about. This was the answer for the first question. But what about the resolution? At what resolution do we see the world? 1080p, 2K, 4K, or 8K? For that, we need to understand what resolution is. Every image or video is made up of these square pixels. 1080p resolution means 1920 pixels width multiplied by 1080 pixels height. When you multiply these values, you get the amount of pixels that combined makes an image. In 1080p image or video, there are 2,073,600 individual square pixels. 1 million pixel equals 1 megapixel. So 1080p image has 2.1 megapixels and 4K image has 8.3 megapixels. You can view both 1080p image and 4K image on same device. Then why is 4K image better? It is because there are far too many pixels compressed in the 4K image than 1080p image. So if you place both images on bigger screens, you'll notice that the first image will get all blurry and bad quality, but 4K will still be highly detailed and clear. This also helps to zoom into small details because there are too many pixels compressed in that area, which can be stretched and still look like a 1080p image. Since the field of view, angles, and a lot of other information about human eyes has already been figured out by the researchers, we should be able to find out the minimum resolution our eyes are able to see. So if we mathematically calculate the total pixels required to fill the area visible to our eyes, such that individual pixels are not visible, but the whole view looks like a clean image, the answer will be 576 million pixels, which is 576 megapixels. But remember that this is the minimum assumption. Since we don't have a built-in feature to zoom in or out, 576 megapixels is enough to give us the clear view in a good quality. The quality also highly depends on the eye itself. Some people have a really sharp and powerful eyes while many are weak or defected. But again, our eyes do not work like cameras. As I said earlier, your eyes only focus at a point which you want to see. Everything else is not clear. This point is called focal vision. The farther you go from this point, it becomes more and more blurred. If hypothetically, we could take snapshots from eyes and send it to computer as an image, the object we are watching would be in high resolution while everything else will either be blurred or look like it's captured from a 5 to 10 megapixel camera. So that's the answer for the second question. Subscribe to see more such videos. Now, watch the video on the right side to understand how smartphones are scientifically dangerous to humans in so many ways. Please check out my merch. Link is in description. I would really appreciate it. If you have an interesting idea for a video, tell me in the comments. And also tell if you were satisfied by this video or not. See you on Friday.